Here in problem number 121, we need to simplify this expression. So what we're looking for is what number, right, this represents some number, what number would we raise to the 18th power? Now that 18 is this 18, right? This is the index, the number in the corner is the index, so what number, this represents some number, what number do we put here? Such when we raise it to the 18th power, we get y to the 18th. Well, I'd like to just put a y here and think that this thing is all, that the 18th root of y to the 18th is equal to y, but we can't do that. If you look back to what we did in the last set of exercises, we said this. We had a general rule that said this. We just did it for this one. The square root of x squared is equal to the absolute value of x. And this is what we use if we don't know what x is. We don't know x is positive or negative. And because we're lacking that information, we have to have this little extra rule here. Now, we wrote it for square and square. But more generally, it really goes like this. The rule goes like this. If we have an even root and say x to that same even root, then we get the absolute value of x. And that's what we have in this case. We have an 18 here, some number, y, to the 18, right? So we're going to get, what we're looking at is this. We're looking at the 18th root of y to the 18. So we're looking at an even root, right? An even root of y, some variable, to that same even root. So the best we can do here is to write this as the absolute value of y. Now in this problem though, what we're looking for is the cube root of z cubed. Now this is an odd root, and an odd root, we don't have to worry about this idea here. This only applies to evens, not odds, and we have an odd, so we can do this one directly. So what we're looking at here is just this. The cube root of z cubed is just exactly z. Here's kind of an explanation of why that would be true. If we take, say we take a positive number again and an even number. Let's take 3 and negative 3. I'm sorry, a positive number and a negative number. Now, if we cube these, 3 cubed, negative 3 cubed, and then take the cube root, that's a cube root, and the cube root over here, this is the cube root of 3 cubed, which is 27. This is the cube root of, now, we're going to cube that. So negative 3 times negative 3 times negative 3 is negative 27. Over here, we get 3, and here we get negative 3. So what has happened here is that if you take the cube root of 3 cubed, you get 3. If you take the cube root of negative 3 cubed, you get negative 3. So it doesn't matter if you put in a positive, you get a positive back. If you put in a negative, you get a negative back. So the rule, I guess we could write a rule that looks like this. If you have an odd and some variable to the same odd, you just get exactly x. So it's a little bit different than this one. If you have evens, you have to use absolute value. If you have odds, you don't. Now in number 127, we're looking for the cube root of x to the 15th. So what we're looking for here is some number that when we raise it to the third power, right, this is that 3 right there, we get x to the 15. Now, let's just think about this here. First of all, if we cube this, we know we're going to have to put an x in here, right? Because if you cube something with x, we're going to get that x back. So what we're looking for is what number, now it can't just be x cubed, right? It can't just be x cubed. We're going to have to put an exponent on here. And here's what we know. When you raise a power to a power, you multiply the exponent. So we might be thinking this here. What number would I put here that would give me this, all right? Whatever number this is, I know I multiply the exponent, so it would be that number times 3 has to give me x to the 15th. So you can make a guess at that number now. That number there has to be a 5. So our number in here would be this, x to the 5th cubed. That's going to give us x to the 15. So our solution here is this. The cube root of x to the 15th, if we simplify it, we get x to the 5th. Now this problem number 29, what we're looking for is the 8th root of x to the 24. Now I've got an even power here, so I'm going to have to think all the way down here about this rule here. But this says if my even root is at the same even power, I can just write the absolute value of that base. So I have to have this number being equal to this number. So what I want all the way back up here now is this. I want this number and this exponent out here to be the same. So what we're going to be looking at is this. I want the 8th root of something to the 8th. Now that's something, we're going to have an x in here. So what I need to do now is, what number am I going to put here? And I know when I raise the power to a power, I multiply the exponent. So 8 times what is 24? So all we're going to do essentially is this. This index into that exponent, 8 into 24, 3 times. So we're going to put a 3 here. And then we're going to conclude this. Now because we have an even numbered index and that same even number, we need to write the absolute value. So this is going to turn out to be now, this will be the absolute value of x cubed. So this problem 151, this is just a computation problem. We want to find the value of I, and here's the description of I, right? Here's the instructions for getting I. I is computed using this set of instructions. From the inside out, we're going to take 2, multiply it by p, and then take that result, divide it by L. Then we'll take the square root of all that. And then we happen to be given that P is 100 and L is 110. So let's put those numbers in and compute and see what we get. So I is going to be this big square root here of 2 times P, but P is 100, divided by L, which is 110. Okay, so I is equal to the square root of 200 divided by 110. Now I did this on my calculator. And on my calculator I just typed in this. I hit the square root sign, I get parentheses. I put in 200, I divided it by 110, I closed the parentheses. And when I did that, I got, well, I'll approximate it. I got about this number here, 1.348, it just keeps going. So just to approximate this, let's approximate it here at 1.348.